First, we can launch the preprocessor from the kicker. When SCStream launches, the initial wizard is displayed. We can set the project name in the first step and check Import CAD data to import the geometry. Click Next to go to the next page. On this screen, select Read from File to select the CAD from the Explorer and import it into your model. The next step would be to introduce the X, Y, and Z coordinates to place it, and finally also the conversion to scale it. When you are happy with the configuration, click Configure. On this screen, you can set the coordinate system, the units, and the computational domain. Be aware that if the computational domain is larger than 500 meters, it might not be possible to create it. So set the units to kilometers. When you finish this configuration, click Next to go to the next page. No changes are required for the analysis type, so click Next again. Enter the default value of the temperature and initial temperature of solids. Next, select the basic type of computational domain as external flow, winds blowing through buildings. And in the next screen, enter the wind direction, environment, reference height, ground elevation, and wind speed at reference height. When you finish the configuration, click Next and just check that there are no problems in the settings. Click Finish to close the initial wizard. Now that we are in the model, the first thing that we are going to do is to set the faces of the chiller parts for the boundary conditions. So we are going to apply the name for the faces that are going to be relevant to set the analysis. First, focus on the chiller 1 and isolate it in the view. To make the faces easier to see, change the drawing mode to translucent, and then click on Edit Part Face. In this window, enter the part face name and select the part face on the draw window. When you finish selecting all the relevant part faces, click on Register. We need to follow the same procedure for the part face names for the Chiller 1 Inlet 2 and Chiller 1 Outlet. So select the relevant faces, in this case for the Inlet 2, and register. And finally, repeat the process for the Chiller 1 Outlet to finish this part of the configuration. We would repeat this process to register the same faces for the other chiller parts. Next, we're going to set the faces for the CTF parts for the boundary conditions. First, we need to change the attribute for the CTF1 Inlet 1 to Condition Region Face. And then, in Edit Part Face, we're going to enter the part face name CTF1 Outlet and select the part face on the draw window. We need to repeat this process for the other CTF parts. Now we are going to set the faces of the IAC parts for the boundary conditions. We can select multiple parts, right-click, and click on Change Part Setting Together. In the attribute part, we can change to Condition Region Face as the attribute and click Set. Repeat this process for the other IAC parts. Now set the faces for the DG parts for the boundary conditions. First, focus on the DG1, click Edit Part Face, edit the part face name, and then select the part face on the draw window. Finally, click on Register. We need to follow this same procedure for the rest of the part face names DG Inlet 1, DG Outlet 1, and Fuel Exhaust Pipe 1 to 4. In this movie, only one face of the DG Inlet 1 and one phase of the DG outlet 1 are registered, but in actual work, please register all the applicable phases. Change the attribute of the surfaces of the louvers for the area pressure loss condition. Repeat this process for the rest of the surfaces. Opening the condition wizard, in the first option of the tree, set the analysis types. Check humidity and air conditioner unit. Set up the steady state analysis and enter the last cycle number. Set the parameters for the humidity analysis. Select relative humidity as the unit of humidity input and check both items consider evaporation and consider latent heat of dew condensation and evaporation. In the vapor pressure tab, check set parameters of vapor pressure and uncheck terminate the analysis. Set now the initial humidity value. Select the domain cuboid and then click Initial Value. Select Humidity and the variable name and enter the initial humidity value. Now we're going to set the flow boundary conditions. Double-click on X-min and add the humidity setting to the power law velocity boundary condition. In the Diffusion tab, you can enter the inflow humidity. Next, set the flow boundary conditions for the part faces and the condition region faces. Select the inlets from 1.1 to 1.9 and click Opening. In the screen of the condition opening, enter the condition name and select Fixed Flow Rate. Check Normal to the face and enter the flow rate. Check for Air Conditioning Unit and select Supply Air Opening or Return Air Opening depending on the condition and click OK. Then select the region names AACE Outlet 1.1 to AICE Outlet 1.6 and click Opening. We will follow the same procedure to set the conditions on these surfaces. We need to follow the same procedure for the other IAC paths. Next, set the conditions for the CTF1 part. We will follow the same procedure as before, and you need to repeat this for the other CTF parts. Set now the outflow conditions for the DG part. Set the condition following the same procedure. We set now the conditions for the chiller 1 part, and we follow the same procedure as well. Follow the same for the other chiller parts. We select now the region name Fuel Exhaust Pipe 1 and click on Opening. In the screen of the condition opening, enter the condition name and select Fixed Flow Rate. Check Normal to the phase and enter the flow rate and inflow temperature. We need to follow the same procedure for the other fuel exhaust pipe parts. Lastly, set the inflow conditions for the DG part. Set the condition following the procedure of outflow conditions for the DGs. Set the area pressure loss for the surface and surface 2 to 5 parts. Select Surface and Surface 2 to 5 and then click Area Pressure Loss. Enter the opening ratio and click Compute and OK. Now create the air conditioner models. First, create the air conditioner model CTF. Specify the supply air temperature and humidity using the capacity. Set the type of operation and enter capacity. Check Set 100% relative humidity as upper limit if necessary. Next, create the air conditioner model chiller. Create the air conditioner model following the same procedure. Next, create the air conditioner model DGH1 and follow the same procedure as before. Same process for the air conditioner model DGH2. And lastly, create the air conditioner model IACE. Follow the same procedure. Next, set the conditions for the air conditioner models. First, select the chiller regions, click on Air Conditioner, enter the condition name and select Air Conditioner Model, then click OK. Follow the same procedure for the rest of the chiller regions. Then select the condition for the DGS1 and set the condition following the same procedure. Follow the same for the rest of the DG regions. In the same way, select also the IAC regions and follow the same procedure. And lastly, follow the same as well for the CTF regions. We are going to now create the mesh using multi-blocks. Click the Mesh button, and in the Basic Settings tab, we are going to enter the division parameters of the root block. Go to the Parameter tab, right-click on Root Block, and select Create Block to create a child block. In this screen, you can use the Select button to select a part of a group in the tree or the draw window to use as a reference. By checking Extend Surroundings, the range of the child block can be expanded. Set the minimum and maximum values for the 3, x, y, and z coordinates. Once you finish this setting, you can enter the mesh parameters of the child block and then click OK. You can use then the same procedure to create all the child blocks you need to create your mesh. Lastly, click Gridding to generate the mesh grids, and afterwards Meshing to generate the mesh elements. Click Close to close the meshing screen. We are now ready to export the S file and save the cap file. Click the Export button, specify the path and file names in the Explorer, and export the S file. Then click in the Save button to save the cap file. We can now execute the analysis calculation on the SCStream solver. First, launch the SCStream solver. Click the SCStream solver icon in the Quicker. Then click Open and select the S file in the Explorer. And finally, click Execute. A confirmation screen appears to start the calculation. Click Yes and the calculation starts. Now we can visualize the analysis results using the postprocessor. Click the SCStream postprocessor icon from the Quicker. Click Open Files icon from the toolbar and then select the FLD file in the Explorer. Click Open. We are going to create a streamline object from the chiller parts. But before that, we need to adjust the already created plane 1 object, entering the coordinates of the surface where the streamlines will originate. Then click the Create New Streamline icon to create a new streamline object. In the Starting Surface tab, select Plane 1 as the reference plane. Then, in the Streamline 1 object, click the icon between the object and the checkbox and adjust the starting plane with the mouse. In the Starting Point tab, enter the starting points of the streamline. Select the square as the starting point and enter the number of horizontal and vertical points. And check Create Only on Perimeter to make the inside of the square the starting points as well. In the Display tab, select the type and the number of calculations of the streamline. Finally, in the Starting Surface tab, uncheck the Display items in Frame and the Starting Points. We are going to create now a volume renderer object of the temperature. Click Create, Volume Renderer, and in the Scalar tab, check Display and select the variable. Optionally, you can add control points to set the opacity. In addition, optionally, change the opacity scale in the Details tab. In the color bar for the temperature only object, change the temperature range. Finally, to create a neutral file object, click Open File and select the neutral file in the Explorer and click Open. In the Display tab, uncheck any parts you don't want to display, such as boundary surfaces. Change the color of the parts if necessary. Lastly, if necessary, hide the title of the draw window in the Title tab of the FLD object.